Hello everybody. Today we are going to get off of the graphing kick for a while and we are going to work on solving some absolute value equations. So homework that goes with this lesson 13.3 is going to be on pages 481 to 482. You're going to do 5 through 18 all and then tack on number 22 at the end. So something I want to kind of remind you about before we even start trying to solve this, just to kind of help you understand that absolute value equations are going to have a little bit different answers than just solving a regular equation, is that you might get more than one value. So you guys don't have to write this down, but what I want you to think of is that if I just gave you a simple number and said, hey guys, the absolute value of x is 5. I want you to think about what that would mean to you. Okay, if I said, hey, what's in there for x, I feel like the obvious answer for a lot of you is like, ooh, well, x must be 5 because the absolute value of 5 is 5. But what I also need you to consider is that that x in there could be a negative 5 because the absolute value of negative 5 is also 5. So when we do absolute value problems, we have to keep in mind that the value inside of that absolute value symbol could be a positive value or a negative value, because in the end it would still, once we do the absolute value, come out as this positive answer. Okay, so keep that in mind, because what I'm going to tell you is that when you solve your absolute value equations, most of the time they're going to have two different answers. Okay, so if you can kind of have that in mind when you approach one, like, ooh, this has an absolute value sign, it's going to have two different answers. That's kind of what we want your mind going to whenever we start these. There will be a few exceptions that we'll do examples of, but for the most part, absolute value equations are going to have two different answers. So that's going to help you set up your work. Okay, the steps that they have for you right here are pretty good. They kind of show you this as a three-step process. They're going to give you the equation, and the first thing you need to do is isolate the absolute value expression. So they're talking about this part right here, like that part that's in the absolute value sign. Your first job is get that absolute value sign like isolated alone. So see how there's extra plus 4? You need to get rid of that plus 4. So you'd subtract 4 and have just absolute value of x minus 3 equals 4. Okay, then this is where the two solutions things comes in. Okay, so it says you're going to rewrite the equation as two separate cases, because here's the deal. That x minus 3 inside of there, okay, the absolute value of that has to come out as 4. Okay, well, that means that that x minus 3 in there might equal negative 4 or 4, because the absolute value of negative 4 would be 4 and the absolute value of 4 would be 4. So you always rewrite this as two separate equations and say that it could either be negative 4 in there or positive 4 in there, and you solve them both. So step 3 is just solve, okay, and you will get two answers. That x could equal negative 1 or x could equal 7. There's two possibilities. Okay, and if you go back to it, I think that'll make sense to you once you see, like, look, if you did negative 1 minus 3, that would be negative 4. Absolute value is 4. If you put a 7 in there, 7 minus 3 is 4. Absolute value of 4 is 4. Either one of these makes that true. Okay, so we're going to do several together. So stick with me and let's do these. Okay, first things first. In problem number 1, isolate the absolute value part. So here's your absolute value piece right here. Get it isolated, which means that minus 3's got to go. So I'm going to add 3 on both sides and have the absolute value of x minus 2 equals 8. Okay, once the absolute value part is alone, you split it into 2. Guys, that x minus 2 inside of there, that x minus 2 could equal 8, or that x minus 2 could equal negative 8, because the absolute value of either one would be 8. So solve them both. Add 2 to this one, and you're going to get x equals 10. That's one possible answer. Add 2 to this one, and you're going to get negative 6. So two possible answers. Either one of those would work for x. Okay, go again. Isolate the absolute value part. So if I want the absolute value part alone, get rid of the plus 2. So subtract 2, subtract 2. Absolute value of x plus 7 equals 8. So now that the absolute value part is alone, that x plus 7 in there could equal 8, or that x plus 7 could equal negative 8. Solve them both. This one's going to come out as 1. This one's going to come out as negative 15. All right, number 3. Here is your absolute value part. The x minus 5 is in the absolute value sign, so this time you have to get rid of the 4. To get rid of the 4, that says 4 times the absolute value of x minus 5, so you would divide by 4. So you're going to have the absolute value of x minus 5 equals 5. All right, that means that x minus 5 in there, that x minus 5 could equal 5, or that x minus 5 could equal negative 5. All right, solve them both. So this one, you're going to get x equals 10. This one, you're going to get x equals 0. All right, one more time. Here is your absolute value part. You need to get rid of that plus 1. So subtract 1. You're going to have the absolute value of 2x equals 6. All right, so that means that 2x inside of there, 2x could equal 6, or 2x could equal negative 6. Solve them both. X equals 3. X equals negative 3. So this is the majority of your absolute value equations have 2 solutions, because the part inside the absolute value sign could be a positive value or a negative value. So you have to solve for both cases. All right, things that we need to do on the back side. Okay, feel free to pause and let everybody get this down if you want. We need to do absolute value equations with less than 2 answers, because there are always those special exceptions that could come up where your absolute value equation does not have 2 answers. So these are the 2 examples that we're going to do. Let everybody get them down. All right, same process though. We are going to isolate that absolute value part. Okay, so this time just use your same equation solving rules like normal. You would undo the adding and subtracting first. So minus 7 on both sides. So you're going to have 3 times the absolute value of 1/2 x plus 5 equals negative 2. All right. Still need to isolate this absolute value part. So now you need to get rid of the 3. You are going to divide by 3. So you're going to have the absolute value of 1/2 x plus 5 equals negative 2/3. Okay, here is where I need your common sense to kick in. Guys, the absolute value of 1/2 x plus 5 is supposed to equal negative 2/3. Guys, I don't care what you put in there. When you take the absolute value of that number, you can't get a negative. So you need to make yourself a note right here. Like, circle this and make it clear. This can't be negative. You can't take the absolute value of something and get a negative answer. It's impossible. So this is the time where you would write no solution. The absolute value cannot come out as a negative. Impossible. Okay? All right. Other special circumstance. This guy. Isolate that absolute value piece. So again, undo the adding and subtracting number. So we need to add 3. So we're going to have 3/5 times the absolute value of 2x minus 4 equals 0. Negative 3 plus 3 is 0. Okay, still trying to isolate this absolute value part. So we would want to get rid of the 3/5. Hopefully your brain is saying reciprocal. You would multiply by 5/3, which means you got to do that on this side. So you're going to have the absolute value of 2x minus 4 equals, hey look, 0 times 5/3 is 0. Okay, so guys, this is the point where normally we would split this into 2, and we would say something like we did on the front, like, ooh, this could be positive 6 or negative 6. Okay, I'm really sincerely hoping that you don't think you're going to do a positive 0 and a negative 0. There is no such thing. Okay, so when it happens to equal 0, you are not going to get two different answers because you can't have a positive 0 and a negative 0. There's just one 0. So this just means you're going to solve it once. 2x minus 4 equals 0. Go ahead and solve it. You will get an answer. But my point is that's your only answer. You're not going to do it once for positive 0 and once for negative 0. There is one solution. Okay? So the lesson from this is almost every absolute value equation has two solutions. But you can't get a negative answer to an absolute value problem. So that's no solution. And you can't get two solutions when it equals 0 because there's not a positive and a negative 0. Okay? All right, so let's take a look at what your homework is going to look like, and then you can get your paper set up, and I will help you out with one. Okay, so take a look first, and then everybody can take time to get their work set up. You guys are starting your homework on page 481. Okay, and on page 481, you guys are doing 5 through 18, and then you're going to do 22. Okay, guys, on all of these 5 through 18, you're going to notice that the directions say solve the absolute value equation, graph the solutions on a number line. I want you to ignore the graph solutions on a number line. So there will be no graphing of any kind. There is no graphing on a coordinate grid. There's no graphing on a number line. I just want you solving them exactly like I showed you in your notes. So these are all just solve it. Okay, when you continue through here, okay, same thing. These are all just solve it. The only thing different here is they're saying that there could be a no solution when mixed in. So just flat out solve the absolute value equations. Okay, when you get to 17 and 18 though, there are two word problems. And then 22 is one of those explain the error ones. Okay, so what I want everybody to do right now, take a second, get your paper set up. You don't need graph paper. You're not graphing anything. Okay, I will help you get 17 set up so that you understand that one. And then you should be able to handle number 18 from there. Okay, so take a pause, get homework set up, and then come back to this and I will help you set up the word problem. Okay, all right. So if you're back with me here, number 17, let's read through it so we understand what the situation is, and then I'll show you where to plug everything in. Okay, this is the bottom of a river makes a V shape, okay, that can be modeled with the absolute value function right here. Okay, so you're going to write this down on your paper. That's your function. Okay, it's important to understand what the letters mean, though. D stands for depth of the river bottom in feet, and then H stands for the horizontal distance to the left-hand shore. So see how here's the left-hand shore and it numbers over from here and they call that H horizontally. Okay, like so when I'm here, I'm 160 feet from the left-hand shore. Here, I'm 360 feet from the left-hand shore. It's how far are you from the left-hand shore. Okay? All right. So D is depth, H is horizontal distance from the left-hand shore. All right, here's the deal with this ship. A ship runs the risk of running aground if the bottom of its keel, its lowest point under the water, reaches down to the river bottom. Suppose you are the harbor master and you want to place buoys where the river bottom is 30 feet below the surface. How far from the left-hand shore should you place the buoys? Okay, so in other words, they want to keep the ships traveling down the middle of this V shape so that they don't hit the bottom with the bottom of their ship. Okay, so the harbor master wants to put like some buoys out here somewhere, like kind of little markers in the water to tell the ship like stay in between these points so that you don't run aground. And he wants those buoys to be where it's about 30 feet, okay, like there's 30 feet depth so that they know don't go to this side of these or your water's way too shallow for you to fit through. So here is what we need to understand from that. Okay, he wants to put the buoys where the river bottom is 30 feet below the surface. Okay, so in other words, what your job is going to be, okay, is that you want to help him figure out what horizontal distance should he put the buoys at if he wants to place them where the depth, see D for depth, is 30 feet below the surface. So what you have to read and understand is you're replacing the depth with negative 30 here. And then you are going to solve this equation for H. Okay, so let's go ahead and keep this going. Let's solve it. We need to get that part by itself. So you need to add 48 on both sides. Negative 30 plus 48 should get you 18. So you have 18 equals 1/5 times H minus absolute value of H minus 240. Okay, now you need to still get that absolute value by itself. So to get rid of the 1/5, we're multiplying by 5 over 1. So basically that's 5 times 18. That should get you 90. Okay, and now that you've got the absolute value part by itself, now you are separating it into two. So you're going to get H minus 240 could equal 90, or H minus 240 could equal negative 90. So if you solve both of those, you're going to get 330 and you're going to get 150. Okay, so you need to answer the question. This means if he put buoys at 330 feet and 150 feet, it would keep the ship between it. So I'm going to show you the picture again so you can see what you just solved. Okay, what we're saying is that if you look back at this picture, okay, if that harbor master put a buoy right about here at 150, and then right about here at 330, if you put the buoys there and kept the ship in between those two spots, at those two spots, the depth of the river is right about, if you look over here, see how here's negative 40, the depth of the river is about negative 30, about 30 feet deep, right there where we found our two answers. Okay, so you guys are going to do, okay, a similar thing with this one with the geese. Okay, but you're going to be filling in what this should be based on what you read. What the B of D should be. Fill it in based on what you read about the geese, and you guys will solve for that distance in the same way. Okay, so you should be set. Use the rest of your time to work productively on getting done with 13.3 homework. Good luck.